Good afternoon, everyone. S.P. Singh from New South Wales Department of Plant Industries. Glad to be here. I'd like to thank Vegetables WA and their extension team for inviting and organizing this event here. I also had opportunity to see some of you in your farms. It's an absolute pleasure to be here in WA and visiting the vegetable growers. So this afternoon I'm going to talk about fresh produce safety and traceability in general. So it's going to be a food safety 101 with some special reference to melons, the way the melons are grown and processed. So the work that we do with the melon industry nationally is delivered through Safe Melons program. So Safe Melons is an initiative of the New South Wales Department of Plant Industries in partnership with Melon Australia. But we have a number of collaborators and partners in the country who support the program directly and indirectly. And you can see Vegetables WA's in the list, as well as the Carnarvon Growers Association and your Western Australian Department of Plant Industries. So we acknowledge these organizations because it's not possible to deliver a national program without the support of a range of organizations and people around the country. So foodborne pathogens and parasites, they are the bugs that are of concern to the industry in terms of microbial food safety list. And the list of these pathogens, they used to be primarily Salmonella and some strains of E. coli. And now we have Listeria monocytogenes coming quite often in the news. And then some viral pathogens like noroviruses and hepatitis A. And lately, not in Australia but in overseas, parasites like Cryptosporidium and others, they are also becoming prominent microbial pathogens of parasites of concern. So we know that we grow crops in the open fields, and what we can do in the open and natural environments is to have the best practice in place to minimize those risks. So we can have these preventative controls in place to minimize those risks, and we also understand that we cannot eliminate the risks from production fields and post-harvest environments, but we can minimize to an extent that it doesn't become a public health concern. And in some cases, if there's an issue, we should have good traceability in place so that you can manage the risk effectively by doing your product recall on time and absolutely doing a targeted product recall if you know where your produce has been in the chain. So I'm going to talk about some of these major preventative control that can be put in place to minimize the risks. As I said, this is Food Safety 101, so I always show the slide to share from where these pathogens and parasites come to your fields. So the most common sources are wildlife, and then livestock, poultry, and compost with animal manure, which is not properly treated. And on top of that, the weather events, flooding, runoff, and dust storms. Majority of the growers are quite aware of the risks coming from poultry, livestock, and wildlife, but I think the risks associated with weather events, they're quite underestimated, but they're quite serious in some of the areas, especially dust storms in some locations where they don't have proper wind breaks and dust storm management. These can be a serious issue. Another illustration to show how these pathogens, they transfer from the environment to your fields, what I showed in the previous slide. From your field, along with your produce, whether it's a fruit or veggie, and machinery and workers, these pathogens then move into your packing houses. So this is the most common route of transfer of these pathogens from the environment to the field and to the pack house. So what can we do in the field to minimize the risk? The first and foremost recommendation is not to use any raw animal manure, which is in line with your food safety certification programs. And then secondly, the wildlife management. I often hear from growers the issues with the birds and some kangaroos and pigs and deers in some locations. So wildlife management is very important. And the third thing is irrigation water, pre-harvest water. Some locations we have underground water, which is of lower risk comparatively, but a lot of horticulture and melon production regions, they have surface water coming to the creeks and channels, which can potentially be contaminated upstream if there's a poultry operation or livestock operation. So these are the three critical pre-harvest food safety management points that growers, if they take care of these three things, they can minimize the risk. We have also identified some agronomic practices which can actually minimize the risk. So number one is the plastic mulching. For example, in melons, majority of the melons are grown on plastic mulch, but use of plastic mulch can minimize the contact of melons with the soil. Not to a great extent, but something is better than nothing. And then drip irrigation. Drip irrigation is a better choice over sprinklers in terms of spreading the contamination if irrigation water is contaminated. So these two practices are quite effective in minimizing the risk to some extent. And these are common things like good hygiene practices. Field workers, they should be trained in personal hygiene and the provision of portable toilets. This is just as part of your food safety certification program, so I need not to go in detail. Harvest bins and equipment. This is an area which is quite neglected in the fields. They get washed rarely or once in a season, but what we found that, especially for crops like melon, they should be harvested, they should be cleaned and sanitized every time they're used. Moving on to post-harvest, I think in terms of minimizing the risk in the packing sheds, there's an impression that we can fix the things in the packing shed. You can wash the produce and sanitize the produce and fix the microbial contamination, which is not true. So while washing and sanitizing, you can reduce the microbial load on the produce, but you cannot eliminate the contamination if it has already occurred in the field. So what is recommended, and as per your food safety certification programs, drinking quality wash water should be used. And this wash water must have an effective sanitizer concentration. So in our melon food safety guide and the toolbox, we have recommended, based on the scientific evidence, what is the minimum effective concentration of each sanitizer that you can use. Second most important thing with washing and sanitization of fruit is the contact time. So if you have an effective concentration of sanitizer in your wash water, and you're not having the contact time right, it's less effective. So for example, we have recommended that you should be using, say, 100 parts per million of chlorine for washing your rock melons, but that contact time should be 2 minutes. If you cannot have 2 minutes contact time, you have to increase the concentration of sanitizer proportionately. So basically it's concentration versus multiply by time. So you can have 1 minute contact time if you increase the concentration to 200 parts per million, which is quite high. So contact time is equally important and is often ignored, because in the big post-harvest operations, they would like to pack quickly. So they would like to rush their produce through the line. So the fruit may not get enough contact time with the sanitized water, which is actually going to help it to reduce the microbial load on the surface. In terms of sanitizer injection in the wash water, the industry is moving into automation. So you should be using automated dosing system for your sanitizer, whether it's chlorine or peracetic acid. How it helps? It helps in terms of removing that manual error of adding chlorine or all the human factors. Secondly, it helps you in recording the data. So most of these systems, they're data logging your concentrations of sanitizers injected in your wash water. If need be, the data can be pulled and used for your food safety records or if it's needed for investigation. As I said, automation is important because now you can have a machine, but you cannot just rely on the machine. You should be verifying what your machine is doing. So you need to have these digital tools like chlorine meter and pH meter in your packing shed, where you can verify the machine. So what is the concentration of sanitizer which is being injected in wash water? So we recommend that you should be automating your sanitizer dosing in wash water, but at the same time you should be monitoring it using these digital tools. Moving on to your post-harvest environment management. So what happens in a typical packing shed? Each packing shed has certain zones. We think this is an ideal packhouse layout where you have the receiving and washing area, which should be separate from your grading and packing area, and then finally your handling and storage area. So what happens in a packhouse? As I said before, the pathogens, the environmental pathogens, they enter into your packing shed in the food receiving area. So layout and design of the packing shed is very important in terms of the movement of the produce as well as potential movement of the pathogen in the packing shed. So I'm not going to go much in detail, but it's just you have to identify those zones and segregate them so that you limit the movement of people and machinery across those different zones. An important consideration in the packing house is equipment design. I put some pictures. You can see any equipment that you buy or you install in your packing shed, it should be friendly for cleaning and sanitizing. Something that you cannot dismantle or clean or sanitize effectively is not good for your packing shed. So we have seen a lot of examples where if you have porous surfaces in your packing line, they're not good because bugs can stay there and they can form biofilms and cause cross-contamination of the produce. So I would like to draw your attention to this particular slide because we get questions around when you find a positive test from your packing line or from your produce. In a typical packhouse environment, we recommend that you should be doing proper cleaning and sanitization of the fruit contact surfaces as well as non-contact surfaces such as floors and walls. But when you receive a positive test result from a lab, say for example for Listeria, so the question should be whether this pathogen was a random contamination in your packing line on fruit, or was it a resident pathogen? So to confirm that, we do resampling of the facility, and it's really critical to determine whether the pathogen is transient or resident. Because if the pathogen is resident, it means it will keep on contaminating the fruit coming in the facility. So facilities, those who don't clean and sanitize properly at the end of the shift, so the transient pathogen actually become resident, and it's really hard to get rid of them once they spread in the facility. So we have been trying to make this concept which is called seek and destroy. So when you do testing of the packhouse for say environmental samples, the objective should be to find the pathogen where they are. Generally, we are looking for a negative test result. That actually defeats the purpose. So when you are going for environmental testing, if you can't find, you cannot destroy it. So this is an important concept in managing the packhouse environment. And once again, I would like to reiterate that once facility gets contaminated with these resident pathogens, it's really hard to get rid of them. So we just try to simplify this cleaning and sanitization schedule. What should be cleaned daily and what can be done less than daily, which could be weekly depending on your operations. So all fruit contact surfaces, such as harvest bins, or wash tanks, brushes, conveyor belts, they have to be cleaned daily. And some other fruit non-contact surfaces, such as drains and floors, which are actually directly under the packing and grading area, they should be cleaned daily. Less than daily, most of the non-fruit contact surfaces, such as cool room floors and walls, they should be cleaned depending on how big your operation and how good you are at maintaining the cleanliness and sanitization of your facility. The last bit in my presentation is on traceability. You heard from Fiona, traceability is becoming increasingly important. As I said in the beginning, that you cannot eliminate microbial food safety risks from your business. You can minimize to a certain extent. So why traceability is important? Traceability is important because if there is a problem, if there is a contamination and the product has gone into the supply chain, you should be able to recall it. But it's not as simple as it looks. Traceability is also required for your biosecurity on farm. So some of the issues that melon industry had around CGMV and other diseases, they come to the farm with seed and seedling. So you can see this is a busy slide. I tried to put it together that seed which could potentially be bred in California or US, it goes to South America for multiplication, comes back to North America for processing and packing, and seed lands, say in Queensland, seedlings come to New South Wales, and from there the fruit goes all over. And then some of the other inputs like pesticides and fertilizers, they can come from interstate or internationally. So in that case, traceability, both in terms of your internal traceability, so keeping records of your chemical, the sources, fertilizers, so it's really important. So what are the main drivers of traceability on a farm? For internal traceability, you need to comply with the food safety certification programs, so you need to keep all the records. And secondly, if you need to recall your product, you should be able to identify the batch and the lot and where it was dispatched. And thirdly, for biosecurity purposes, the growers on the East Coast, they need to maintain their pest or disease freedom for access to New Zealand. So for them, traceability is not only for food safety, but also for biosecurity purposes and market access. So, and I think these requirements, especially in terms of biosecurity and market access, traceability will be even more relevant in the years to come. In terms of external traceability, the drivers are like, again, compliance, and if you want to do product recall. And recently, some growers, they have started engaging with the consumers by putting QR codes on the fruit or on the punnets or packaging, and they're doing brand promotion, some supply chain efficiencies. So traceability is, at the moment, is recognized as one of the weakest link in the supply chain. So You will hear more in this space. So we have a project on traceability from the federal government, Department of Agriculture, and we are working with the melon industry and trying to use melon as a pilot. So what we have come up with that traceability in the near future, it has to be digital, it has to be end-to-end, but there will always be space for physical traceability. So digital traceability, it cannot stand alone in the system. You still need physical traceability, which means the packaging and the labeling on the fruit is going to stay there. Third thing that we are focusing more in this project is validation and verification of your traceability. As Fiona mentioned, we are supposed to do one mock recall of your product as per your food safety certification requirement. But more importantly, you should validate. Like when I asked this question to growers, do you have a traceability system? Yes, we have. Can you recall product? We are not sure. So verification of traceability will become more important in the coming months and years. So from DPI, we run this food safety help desk service where we receive a lot of inquiries from growers and regulators and exporters. So feel free to give me a call or send an email if you have any technical inquiries. We provide this independent, unbiased opinion on your food safety matters that you can avail. So I would like to acknowledge the Federal Department of Agriculture, Water and the Environment. They provide funding for traceability project in collaboration with Melons Australia. And some of the work that we have done on melons in the last 3 years was funded through Pod Innovations. Their melon levies were used for that work. And we are always thankful to Vegetables WA for organizing and facilitating these events here. And I'm happy to take any questions or comments.
Oh, look, SP, I'm probably going to throw one out there first up, but can you maybe just give us a bit of dialogue on chlorine versus parasitic acid?
Yes, so this is a business decision, what they would like to use, chlorine versus parasitic acid, but these sanitizers both, they have some advantages and disadvantages. So with chlorine, I think the advantage is that it's slightly cheaper, and if your water pH is in the range of 6 to 6.5, and then you use chlorine, it's okay, but the pH should be in the range of 6.8 to 7, because when you add chlorine to water, it increases the pH. So if the pH is already 7, pH of your water, you add chlorine, the pH goes up, then you need to adjust the pH by adding acid into it. So it means there's an additional step in that. So that is one thing, that adjusting of pH is critical. And some packing shelves, those who use chlorine, they find it a bit hassle to manage it. And in our best practice guide, we have also recommended that if you are measuring the concentration of chlorine, you must measure pH at the same time. If your meter might be showing 50 parts per million of chlorine, but if pH is 8.5 or 9, it's not effective. So on the parasitic acid side, because it's kind of independent of that pH, so if your water pH is even 7, 7.5, so when you add acid into that, it brings down the pH. So you don't need to worry about pH. But the sanitizer itself is a bit corrosive, more corrosive than chlorine, I would say. And it can actually cause a bit of damage to the machinery over years. So in terms of, though chlorine is also corrosive because that's the nature of the chemical, but I would say parasitic acid is a bit more corrosive. But comparing it at its efficacy level on microbes, there is evidence that parasitic acid it's slightly more effective than chlorine on some pathogens like Listeria. So that's another thing. As per APBMA, we have recommendation of 80 parts per million of parasitic acid that you can use. That's the thing for 30 seconds. But that concentration could be a bit damaging for some produce. For example, if you're doing peaches and nectarines, that concentration could be on the higher side. So in those cases, they go for 25 to 30 parts per million. Similarly with chlorine, with melons, especially rock melons and honeydews, rock melons, I would say, they can withstand very high concentrations of chlorine, like 100, 150, or even 200. But some honeydews and specialty melons like gala melons and those Spanish ones, they can get damaged if you use very high concentrations of either chlorine or parasitic acid. So comparing these two, I would say, again, it's a business decision, but any sanitizer, when it's used at recommended concentration and contact time, it works. So, yeah.
So would you potentially so if we use Anthony as an example, would it be beneficial to run parasitic acid for melons, and for his egg fruit maybe run chlorine, or would there be any sort of food safety outcomes that might be improved by changing between the two, or is it just going to be cheaper and easier to buy one and stick with it?
I think that's what normally people do, because if you have chlorine, you need a totally different system.
Yep.
Because then you'll be looking at pH and that's, so if you buy chlorine system, then you just stick with it. Mm-hmm. With acid wash, especially for rock melons, we recommend, because we have seen better results with parasitic acid. And contact time, though we again say keep it 2 minutes, but 30 seconds is the minimum that is recommended. So I think for a situation like Anthony's, if he goes with parasitic acid, he can reduce the concentration of parasitic acid to say 25 to 30 for capsicum and that kind of produce. But sticking to just one would be just a good business decision, I would say. Yeah.
It's easier for training people, so monitoring if you've just got one system.
Yeah. And with parasitic acid, the system that is currently used, and I could see that there is something called ORP probes, oxidation reduction potential probes. Those probes are good for measuring the oxidation reduction potential of water containing chlorine. But I went to some packing sheds where I saw those ORP probes being used for parasitic acid, which is not technically correct. So for parasitic acid, if you are using parasitic acid injection in the line, you should be monitoring it with your digital meter. There are some even some ECD sensors where you can use to measure the concentration. So I think I see phone calls which one should be going for. So for chlorine, as I said, chlorine is, I would say, considering the current commercial equipment, is pretty sorted for automating. So when you ask for automation from the suppliers, they give you chlorine concentration, you can automate pH, you can adjust the meter that I showed, you could adjust the pH and the concentration of chlorine, and there you go. And then you can data log the concentration, what's happening in the during processing.
So I'm going to ask another one, just because I've got a good spread of everybody here. Look, some of the guys here are running different veg lines like cucumbers and peas and beans and those sorts of off the ground. Tomatoes is another one, but may benefit from some washing. Obviously, we don't need to get to massively high concentrations in the same way as we do with a netted skin rock melon. But could you just sort of talk through about, I guess, the importance of applying some sort of treatment to the water?
Yeah, so as I said, first of all, it has to be drinking quality water. That is the basic requirement. And secondly, if you can afford, it should be run to waste. That is the best practice. If you can, as I said, afford, or if you set up laws, when you are running wash water to waste, you are absolutely minimizing that risk of cross-contamination. But when you are dealing with produce like as the things that you mentioned, if the organic load is less in water, then if you can monitor the concentration of sanitizer properly, it should be fine. But you cannot have just drinking quality water without a sanitizer. So again, it comes back to those three things: having drinking quality water, proper concentration of sanitizer in water, and then contact time, how long you leave it, the produce, how long it comes in contact with that water. So those three things are very important. And what I have seen that sometime when you automate your system in your spray bars, some systems when they're pumping sanitizer into water, we see those spikes and dips. So even the mixing of sanitizer into wash water is not uniform. So some of the big operations, they do a bit of mixing before it's pumped onto the line. But I think we are educating the packers now that just be careful, that it should not be that you are injecting your sanitizer. You should not have those spikes and dips of sanitizer. So maybe some nozzles in your spray bar are running at low concentrations, others are running at high concentration. So we have seen those situations in the industry where even they have tried to automate the injection of sanitizer, but it's not uniform. So it can be like, depending on the pumps that they use and so many variables. So it's always good to monitor that concentration even across your spray bar. And as part of our washing validation program, and we have written in the Melon Food Safety Guide, those who really want to go on top of everything, they can even validate washing by measuring concentration of sanitizer from each nozzle, the water discharge from each nozzle. So that's the way of validation when you start your operation. So, but fundamentally, those basic things of having drinking quality water, sanitizer, proper contact time. That's and even with your irrigation water, I didn't talk much, but I think, Joel, probably you should be giving a bit of brief on that.
So what Fresh Care says for irrigation water is it's got to be less than 100 CFU per 100 mils of E. coli. So that would be irrigation quality, and the theory, and Elizabeth is going to probably correct me if I'm wrong, but is that UV light at that level will degrade within around about 48 hours. Am I correct in my wording there? So we need to be making sure that we're less than 100 for irrigation water. And when it comes to higher risk crops, we're probably looking at, if you're irrigating, say, strawberries, and then harvesting them tomorrow, and there's contact, we really need to be irrigating with drinking quality, which is less than 1 CFU per 100 mils. So, look, in terms of some commentary around that, a water test is about $80 for E. coli, which is a pretty cheap insurance policy, or double check. And certainly we would be testing water. If we're treating water, we would be testing that with water sanitizer in it, so that we know that by the time we're getting it into a dump tank or something like that, I suppose it's when it's hitting the product, it's getting a kill step. So that's what Fresh Care says. But if we're looking at HARPS, HARPS says you must test all of your water sources. So and they must comply with the base scheme requirements. So for those of us running Fresh Care plus HARPS, we obviously need to comply with Fresh Care requirements. It's a bit more complicated with Global Gap and SQF, but I think we really need to be, I guess, maintaining and possibly in some instances increasing the surveillance of water and product testing to make sure that we've got good history. And let's be honest, if you've got a water source like a bore, it might be really good in winter when we've had flushing rains and whatnot. And what we tend to find as a general sort of statement is in January, February, March, when the water table is much lower, we tend to find increased concentration. So we may not have to treat in winter, but we may have to look to treat in summer. So I suppose the comment is to randomise your testing a bit from time to time, and yeah, really just validate and verify that we're getting a good kill in the water, because effectively, if we have an issue in the vegetable sector, I mean, it could hit any number of commodities. So we saw with the rock melons and how much financial and cultural change they had to and damage that they had to sort of, I guess, rectify. To me, I think we've got to be proactive rather than reactive. So I don't know whether you've got any comments, or Elizabeth, whether you want to say anything over the top of that. Did I miss anything?
Oh no, I think the issue is it's hard with water because of change. You might take a test one day, there's no E. coli, and then there's a downfall, and sample the next day it's over the limit. So you do need to be aware of that. I guess that's part of your whole food safety management system, to be aware of those fluctuations in water. So certainly, if you get a negative result, you can't rest on your laurels and think, well, I don't need to worry about that for another year. I know Fresh Care requirement is annual testing, but the reality is annual testing isn't enough to help you understand what's really happening with your water source. So that's something that needs to be thought through carefully in terms of what fluctuations in water. And I guess the only other thing that I'd like to point out is that certainly to support what S.P. has said about treating water, but at the bottom of all, at the heart of all of this management of the quality of the food and produce at the end is prevention. And I think that it doesn't matter how good your chlorination system is, or your acetic acid, whatever you're using, it's all of the things that you put into your management program that is minimising the chances of contamination from the field through packing, as S.P. has talked about. So I think it's not one answer, it's everything put together.
Yeah, and I think on preharvest or irrigation water, that it has become an industry practice to do annual water test. And then if you read the standard carefully, I think it says you should have a history of four
consecutive
four
months.
consecutive tests being negative or good quality water, and then you can switch to annual. And I think, as Elizabeth mentioned, that a lot of events that happen, and we have seen, especially with flooding and drought. Drought makes water quality equally, different, and all those events, flooding, drought, or even dust storm, when you have water in your farm little dams, that can change the quality. So I think that testing of water just before the audit, and then it's done for 1 year, that practice has to change. As Joel mentioned, it's not that expensive. It's $80 for one sample. So I think it should be more than annual, than just do it just before audit. And then once you have that history of testing from a particular source, that validates your, the credibility of your food safety system, actually.
I think it's also probably about the culture as well. We've got to change the mindset of annual testing was fine.
Yeah.
I think that's part of this food safety culture journey that we have to sort of all walk down. We have to be mindful that we're gambling with big businesses and big dollars in terms of as a sector as a whole. We can ill afford to damage the reputation of tomatoes or zucchini or beans or any of those lines because because we felt like an $80 test was too much, or I think we've got to really shift away from that. And if we don't, as an industry, step up and start to improve the culture, we will have the likes of the retailers and to a certain extent just general consumers will start to press back harder and harder. And I think history sort of said to us, if we don't act as an industry and control our own destiny, then ultimately we could be exposed to regulation, and regulation obviously has much more severe consequences, and perhaps that might end up costing us more than taking the bull by the horns and sort of managing things ourselves.
Yeah, and then the final statement is that you will never be able to eliminate this food safety risk from your production and post-harvest. They're going to be there. So you do your best by putting the best practice in place, using all your preventative measures to minimize the risk. And that's why the traceability bit is more important. When you know that you cannot eliminate something, you should be prepared to act, if something goes wrong. So that's why in your food safety management system, have the best practice, have the best controls, but keep your preparedness and traceability plan or systems ready. If something goes wrong, you should be able to act swiftly. Thank you.
Does anybody else have any more?
Yeah, sorry. Are you saying about the parasitic acid? What was the contact time you said sufficient?
30 seconds. 30 seconds. That's the recommendation from APBMA. It's on the label.
Right.
The longer you can give, better it is.
Yeah.
30 seconds is just bare minimum.
So if you had rock melons
Yeah.
and you had spray bars,
Yeah. I will do 2 minutes. At least 1.5 to 2 minutes. So research says if you keep for 5 minutes, it's great, but 5 minutes is not practical. So, and the label says 30 seconds. So I would say just 1.5 to 2 minutes is reasonably good, and it's practical.
Do you have a question, Ed?
Yeah, not sure if you know a lot about or if you've done research about it, but something I found interesting that I heard a talk about ages ago was cold plasma treatment. So do you know much about that?
Oh. I have been doing that for 4 years now. So cold plasma treatment, yes, good question, and I did not touch that. Cold plasma is a surface treatment. So when it comes to vegetables, when I'm talking to the vegetables group, it's really difficult to treat the produce from all directions because of the surface area and the issues with, it's really brilliant for killing bugs on the surface, for example, for apple or citrus, or even we have tried on strawberries and blueberries, and say tomatoes, we do a good job. But for other produce where you have, so it's a surface treatment, so you have to expose the entire surface to plasma to be effective. So plasma will never be a standalone treatment. So it can just supplement your washing and sanitization step. So once your fruit is washed and sanitized, it can go through plasma zone. So I can show you some pictures I have with me. We have developed a prototype where we have put plasma system in place, and you can feed the fruit from one end, and then it goes through plasma, it gets treated. So we are hoping that in the next 2 to 3 months, we'll be able to take it for demonstration to the packing sheds. So that will be an option, especially for products like rock melons or any other produce which rolls, and depending on the investment that you would like to make, adding plasma to your packing line would be good. And you got the new packing line, and we would love to add plasma to yours. Yeah, it is effective, but the challenge is application, how to get it around. We tried on lettuce and spinach and other things. So using plasma as a dry treatment is a challenge. But when we infuse plasma in water, it does a similar job what a sanitizer does. So it actually sanitizes water. So I think we are not looking at that right now, but our focus is on plasma as a dry treatment. So maybe for your strawberries, we should send the prototype to West Coast. You can try using strawberries.
Some people are actually practicing hydrocooler, with cool water, and water is actually mixed with sanitizer and like chlorine. Do you think that also effective enough in terms of actually killing? Actually, that required for ICA 60, ICA 61, to kill sort of bug or PPP, something like that.
Yeah.
So do you think in one practice, hydrocooling is also enough in terms of like food safety and
it depends how long they are exposed and what is the concentration of sanitizer in that water. I think
105% in 5,000.
one thing more that comes in hydrocooling, we have experienced it in some other crops.
Usually it's longer than 5 minutes.
That should be good enough, but issue with hydrocooling is if water is too chilled, the chlorine efficacy decreases. If water is in hydrocooler, it can be
2 degrees.
under 5, definitely under 5. So chlorine has its limitation in that case. So the best efficacy you get at temperature like 20 degrees Celsius, 25, or say go to 30. And then when the temperature is too low, I would suggest things like parasitic acid. It will be more effective compared to chlorine. And now you mentioned hydrocooling, and then in Northern Territory, issues with hardness of water. And some of them are using chlorine, and efficacy of chlorine is also badly affected by the hardness of water. So when the water is too hard, basically, it's again. So you have to look at various things. So if they are adding very high concentrations of chlorine to that hydrocooler, that will give some benefit in terms of that.
In that case, they use 5,000 ppm.
Yeah, that will definitely give
0.05% in 5,000 ppm.
5,000 ppm. Yeah, that will do, because the same thing that was done for citrus canker when they were treating fruit in Northern Territory. So they were using very high concentration. So that's pretty good. Yeah. But in generally, hydrocooling means chlorine is less effective in those situations.